Okay, so finally we're going to get to part 3 here of the lesson, and I'll try to keep this short because I know I've already probably done too much. Graphing the genie's offer. Okay, so here are some graphs showing how the amount of money in the purses changes. Remember, purse A starts with $1,000 and grows by $200 each day, and purse B starts with a penny and doubles each day. Here are two graphs. So there's a red graph and there's a blue graph. Which graph shows the amount of money in purse A? So that's the one that starts with $1,000 and, right, and grows by $200 a day. Right? So which graph shows that? Is it the red or the blue? Well, it's the red graph, right? Because how can you tell? How can you tell? Because you can tell because the red graph is going up by a constant amount each day. The same amount. It's the same, like, it's small, but you can see it's going up steadily increasing, right? And in fact, because it's growing by the same amount each day, it forms a line, a linear graph, right? With a slope of, go back to slope, right? What would the slope of the graph be? It would be $200 because that's how much it increases by each day. So let me just write this down. The red graph shows the amount in purse A. I'll just write as a note, how do you know, right? Explain how you know. It's very important to explain your work or explain how you know something or why you think something's true, even if you're not really sure you know it. Why do we think this? Because it grows by the same amount each day. And the blue graph shows the amount in purse B. How do we know that? Purse B was the one that starts with a penny and doubles each day. Well, I mean, if one's the red, the other's got to be blue, right? So just remember, purse B starts with a penny and doubles each day. Okay. What's the next question here? Points P and Q are labeled on the graph. Here's point P and here's point Q. Explain what they mean in terms of the genie's offer. Okay, so what does point P mean? Point P is on the blue graph, right? So that's purse B. And what is it showing us? Well, it's showing us how much purse B is worth, right? After how many days? Well, it looks like it's some just short of 10, 5, 6, 7, 8, 9 on the 9th day. Right? Point P is showing how much purse B is worth on the 9th day. What's point Q showing us? Well, what do you think? It's on the red graph, so it's showing us the amount in purse A, right? And what does it look like the amount of purse A is at point Q? Let's see, this goes up by 10,000 here. There's how many? 1, 2, 3, 4, 5. So this must be 10,000 divided by 5, which is 2,000, right? So that point Q is showing how much purse A is worth, which is, I think, $2,000. On which day? on the 5th day, right? If we look at the x coordinate here, 5th day. Right? Does that make sense? If we kind of like look at what these points mean, we look at the x, that's the number of days, and the y is the amount in dollars. And even though these aren't labeled, we can kind of figure out each thing here, each line is $2,000. Okay, what are the coordinates of the vertical? That's the same thing as the y. This is the same thing as the y-intercept, vertical intercept. Sometimes people will say vertical, sometimes people will say y. What are the coordinates of the y-intercept for each graph? Explain how you know. Well, let's look at these graphs here. What is the y-intercept of the blue graph or the red graph? Remember, the red graph represents purse A, and purse A starts with what? That's right, $1,000. So, what are the coordinates of the red graph, of the vertical, of the y-intercept? Y-intercept of the red graph is purse A, right? What do we know it starts at? It starts at $1,000. So the y-intercept is at 1,000. What's the y-intercept of the blue graph? That's purse B, right? And what did purse B start at? That's right, it starts at a penny, 0.01. So the y-intercept always tells you what the starting value is. Y-intercept of the blue graph, type now, is at 0.01. Does it make sense? Hopefully it makes sense. Okay, let's a couple more questions here. When does purse B become a better choice than purse A? That's a good question. When does purse B, remember that's the blue graph, become a better choice than purse A, red graph? Well, it's easy to see on the graph, right? When are they about the same? Or when does blue finally overtake the one that doubles? It starts at a penny, but it doubles. When does it become bigger than the red graph that starts at 1,000 and gains 200 each day? It looks like right here, right? Right about here, right? That's where the blue graph looks like it's finally bigger. So what day is that? Well, it looks like it's the day just before the 20th, so it's the 19th day, right? The 19th day is when purse B becomes worth more than purse A. We can just, based on the graph, right? Like we can see it on the graph. Based on the graph. Again, just explaining how do I know that. Knowing what you know now, which purse would you choose? So which one would you choose? If we look at these two curves here, or these two graphs, would you choose the red graph, or would you choose the blue graph? Look at the crazy growth on the blue graph, right? Like that's huge. It just takes a long time, and that's the nature of exponential functions. The exponential functions always start off very slowly, very, very, very slowly, but eventually it doubles, like it's doubling here, and then because it's doubling each time, once it gets big enough, it can overtake any other linear function, actually. That's the nature of an exponential. Maybe I should just like point to this and say something like, exponential functions grow slowly, but then overtake any linear function. A linear function is one that makes a line. So that's kind of that is kind of the hallmark of exponential functions. Maybe I can change the text color. I don't like that one. Whoa, that's kind of weird. Yeah, it works. It works. Okay, so which one would you pick? Well, I would pick. Oh, let's just go back to normal, please. Thank you. For this, red pit highlight color. Yeah, clear that. I would pick the Perth B exponential one. And how do I know it's exponential? Because it is doubling by each day. Why? Because it will eventually grow bigger than Perth B or Perth A. Alright, so that is my lesson on introduction to exponential functions. I hope that this made all made sense to you. If not, feel free to comment, send me a private comment, send me an email or something like that. I tend to respond more easily to private comments in Google Classroom because I get notifications for them on my phone, and I'll respond to you right away. Come see me during my office hours. Nobody shows up typically, so you basically would be getting one-on-one support. And have a good rest of the week, everyone. Bye.